Hello, I'm Avinesh and I am going to demonstrate this simple mini project which I am doing for my digital electronics, which is an Astable multivibrator. First I'm going to talk about Astable multivibrator. Astable multivibrator is basically a switching device. By the name itself we can understand Astable. Astable means at the output we never get an stable output. Output always switches between high and low. Either it is going to be high for a very short period of time, and either it's going to be low for a very short period of time. So it is basically to get a square wave at the output. Square wave means we get a 0, we get a 1, we get a 0. Similarly it goes on. So I'm going to show what I'm using in my project. The objective of this project is basically, as I told you, to produce sharp continuous square waves. Okay, so I'll tell you what are the components that I'm using in for my project. First we are going to use a transistor, which is an NPN transistor, a LED, two LEDs and capacitors, both of 10 microfarad, and resistors, battery with a battery clip. I'm going to tell you how this circuit works. This is the circuit diagram. What happens is we get a positive supply which is given to any one of the transistors. Never two transistors can be identical. A transistor, both of them, any one can conduct at one time. So let us assume that this is my transistor 1 and this is my transistor 2, and when the transistor 1 conducts, we all know that when a positive high voltage is given to the base of a transistor, the collector voltage decreases. So when I give this 6 voltage supply to my transistor, I assume that transistor 1 conducts first, then transistor 2. So when I give this conducting means this transistor goes to the saturation region. Saturation region, when I told you, when it goes to the saturation region, the voltage across this point will gradually decrease. So when voltage here decreases, this low voltage is given to the base of the second transistor. So when low voltage is given to the base of the second transistor, the collector voltage increases. Collector voltage increases means this transistor goes to open state. So there is no current, there is no conduction. So initially this conducts and this does not conduct. So at this point we get a high voltage. And when this high voltage is given to the base of the collector, it comes through this way. It given to the base of the collector. This again goes to the saturation. This gradually goes to the saturation region, and this again goes to cutoff region. So it changes its state. It goes to the saturation, it goes to the cutoff region. So one conducts, one does not conduct. So this is how we get an output in this mini project. I'll show you the demonstration. As you can see, one conducts and the other is switched off. When the other is switched on, the other one is switched off. So you can easily understand by this project. Okay. So now the components here required, as I told you, are the resistors, capacitor, transistor, LEDs and DC power supply. This is the working that I just told you. And the output waveform, I told you the output waveforms are square waves. So that is not exactly a square wave but quite close to a square wave. Now you can see the applications. It is used to implement a variety of simple multi-state systems such as oscillators, timers and flip-flops, used as frequency dividers and used in early television systems. That's all. Thank you.